Hey, all right. Are we live? I think this is live television. All right. I am for you all of the awesome things that we've been working on recently around Meadow.Cloud. And I have brought along my good friend, Scott Hanselman.
How are you, sir? Very happy to be here.
Awesome. I'm fantastic. How are you this morning?
I am thrilled because I always like messing with hardware, and I've got like all kinds of hardware around on my desk that is just outside camera view, and we'll be showing some of that. And you've got hardware all over your entire farm, which I'm
That's
looking forward to
right.
seeing as well.
My farm and my house and my desk and hardware is scattered everywhere. That's right. That's right. And in fact, today we're going to learn about how our platform Meadow enables any .NET developer to be an IoT developer. And what we're going to explore today is I built an automated greenhouse. So I basically took my greenhouse and I put some meadows in there and I automated the watering and such. And we're going to take a look at that today.
All right. So you're doing this right now because everyone who may be on the stream right now might be a .NET developer, might be an embedded systems developer, might have familiarity with these things. But we're going to make everyone who is on the stream right now a Meadow developer, even if they've never used a Meadow before.
That's right. That's right. If you're a .NET developer, you can build hardware. You know, you can build real enterprise secure IT, and I'm excited to actually show you that. In fact, I made a little video of my greenhouse, and yeah, that will explain what we've built. So why don't we bring that up, Adrian, and we'll get that in the mix. All right, so in the greenhouse, let's talk through the system here. So we have a watering, a drip system, both up above, below. We've got these grow lights. We've got a heater, and the heater's job is really just to keep it above freezing. And then we also have a fan for ventilation on hot days, right? So we can do the full HVAC control system, make sure that the temperature is ideal for growing, and then of course they have light and water, both important ingredients for growing plants. And the way that this is set up is that the whole thing is run by a project lab board, and this is connected to a 4-port relay, and that controls these outlets here. And we've got the light, water, fan, and heater. It also has a soil moisture sensor, an analog soil moisture sensor, which is down there. And you can see all of the live stats from the system displayed on it right now. And you can see that the light's on. Let me show you this in action. So what's brilliant about this is that over here we have a re-terminal, which is made by Seed Studio, and we've got this Avalonia app, which is showing the live view of the system, and we can actually control it from here. So if I turn on the ventilation, you see there it is, it pops on, and then we heard the click of the relay, and now the fan's blowing. So we can turn that off, and we can turn on the sprinklers. And so the valve pops over here, and water starts coming out of the drip system below. Hey, awesome.
I got to say that when I see stuff like that, I get overwhelmed. I think that has got to be incredibly difficult to make. It's fun to watch things like that on YouTube, but I always feel like the distance between me and that level of success and automation is just unbelievably far.
Yeah, that's right. It seems like it's really difficult, right? I mean, there's a lot of stuff going on in there. We've got we're measuring the temperature, the pressure, the humidity in there. We are controlling the relays to turn on the water or the ventilation. And then we're also doing sort of a complex orchestration in the sense that like when things change, we need to make sure that that goes up to the cloud, that that HMI, the human machine interface that we showed, the Avalonia app, we need to make sure that that's synchronized. And so it knows what's going on in the cloud. And we need to be able to make sure that like, if we change things, if we click buttons on that, then that actually controls stuff. And so there really is a lot going on. But the fantastic thing about this is that it's super simple, and everything that we've done here is in .NET.
That's so cool. It always reminds me of like Lego pieces, because you see a Lego piece and by itself it is simple and it is basic, but then you start snapping it into other things and it becomes more complicated. And I feel like you've done that with hardware with Meadow, because as a .NET developer who's been doing this for probably 20 years, I look at the web and I start plugging pieces together and snapping them together, and I feel enabled, I feel empowered. I can make a website, I can make an Android app. You're doing that same exact thing now, except with the physical world. And for you, I'm going to snap the greenhouse together. I'm going to get this sensor. I'm going to get that sensor. And you just do it. But you're using the same .NET skills that you've been building up over the years that I have as well.
Yeah, 100%. And it's exactly like that. It's an iterative process. You start with something small, you solve one thing, and then you just add another Lego block, and you now add another Lego block, and pretty soon you've got you've got your destroyer ship of Lego blocks. So let me actually show you this, because I think, I want to make this real. So if we pull up my screen here, my desktop, Adrian, you'll see here is my this is Visual Studio, and if we go in here, this is the Cultivar app, and you'll see that this is the Cultivar Meadow app. We go to the main root, and what you see here is this is just .NET, right? So here's your usings, and here is your initialize, and here is your run, and like I said, everything here is just .NET. This is all within your skill set if you built anything in .NET. And all this runs this hardware, right?
When you're looking at this here, it looks familiar. Like I wouldn't say it looks like a console app, but it does kind of feel like a console app. And I see public override tasks. So you've got some async in there. But when I think about it running on a microcontroller, not a microprocessor, this is not a Raspberry Pi. This is a low power, but also high capability custom microcontroller that you've got here. I think to myself, this can't be full .NET. This is going to be some tiny version of .NET that can do like two things.
Yeah, that's right. And what we've done here is, actually, I think it's no short of amazing. This is full .NET, right? So the Meadow.NET runtime is a .NET Core 3.1 equivalent, which gives you the entire .NET 2.1 standard API. So that means that you can grab your favorite NuGet packages and you can just drop them in. You don't have to write specialized code or anything. You have to consider, there are some things to consider. You have to consider that you do have a limited amount of memory and whatnot, but all of the things that you're familiar with, all the things that you love about .NET are here. In fact, if you look at this, here's system.threading and threading.tasks. Here's a generic, so we've got full .NET in here. And if we scroll down, you can see that we actually have, here's a thread with async, so you've got the full async await and whatnot. So this really is full .NET. This isn't the micro framework. This isn't this isn't .NET 1.0. This is full modern .NET.
Interesting. Okay. Now, when I do stuff like this on Arduino, I can almost feel the walls closing in on me, the constraint of this tiny space that I'm in. And one of the things that I'm always frustrated with in Arduino is that while true loop, that super loop, that like, let's do something really fast and then sleep in the middle, and check for buttons and check for sensors. There ends up being just this super loop. But .NET, if I think about .NET and why .NET is amazing, I imagine many years ago dragging a button onto a form and double clicking, and I got on click. Do I have that kind of eventing experience, or do I have to do a loop and check on status of things?
Yeah, 100%. That's really interesting, because what you described is really how we did Windows applications 25, 30 years ago, right? There was some sort of message pump. And even today, if you do a C or embedded C app, as you said, there is a message pump, and it's this big loop, and you have to run through and read status of all these inputs, etc. But the great thing about using .NET is that all of that stuff's abstracted away, and what you have is a real modern eventing system. So if we look at the code here, so this is in my greenhouse controller class, and what's fun here is I say, okay, so if hardware down button is a thing, right? So this is cool. This is C#, I think 10, where you have the null check and then an assignment. So So the irrigation button, we get the irrigation button, and then we just subscribe to the event, right? So there's no magic message pump here that you have to manage yourself. You literally just have events to control hardware and to run this on real embedded microcontroller devices.
It's so amazing because it just feels impossible. But what do they say is that uh, each additional layer of abstraction is indistinguishable from magic, and
Right.
you found that sweet spot with Meadow and the OS to abstract away the part that's no fun and maximize productivity and enjoyment from a programmer perspective. There's a real perspective on developer productivity and enjoyment and being able to do this. But what's interesting and what we're going to talk about today is how you're making this really production ready. This is something that is not just blinking an LED, which is where I'm at from my IoT journey, you know?
Yeah, absolutely. The whole point here, our mission is to make building hardware and doing hardware development and maintaining hardware out in the field as easy as building or maintaining a web or a mobile app, right? So we set out with this idea that hardware was hard, right? And it really was. And we wanted to simplify this and make this accessible to any developer. And so you don't have to worry about the low level plumbing. You don't have to worry about all the hardware integration and talking to ports and all the low level protocol stuff, et cetera. We really wanted to simplify this and make it easy for anyone to develop. We really
Yeah.
wanted to make it accessible.
Yeah. So, when you handled that button event, and I'm thinking about the abstraction layer that puts me between the software and the hardware, and I'm also thinking about hardware like these sensors that I've got on my desk. I know that there's different plugs, for example, on this Meadow Project Lab board. There seems to be plug and play hardware here, and you're bringing in hardware from many vendors.
That's right. And that's really one of the most powerful things about the platform, actually. So when you look at this, we have the button clicked event, and then we update the display. And then in here, we basically say irrigation is on. And if we look at this, and it may be hard to see the popover window, but we can see that that's an iRelay. And this property is part of iRelay. And so what we've done here is if I pop over to our doc, so I go to our developer portal, and you go to Meadow Foundation and you look at this peripheral driver library, we've basically created a massive library of peripheral drivers so that you never have to think about that low level hardware plumbing. And when I say massive, I really mean it. I mean, there's like 300 drivers here. I mean, there's everything. Displays, there's atmospheric sensors, there's motors and relays and all kinds of chips that you can talk to, etc. And actually, if I go in here and I search for relay, here's a relay, and in here you actually see here's the sample code to use this, and it's very simple. You simply relay.isOn, it tracks its state, it does all of the stuff under the hood by creating the actual, by managing the port and managing the hardware, and you don't have to think about any of that. All you have to do is relay is on.
Yeah. One other thing that I noticed is that you're in Visual Studio here. You're in a place that I'm always in anyway. This isn't a custom Meadow IDE. You're not making me use your space. You went to where I already am. Do you support all the different IDEs that I might want to be in?
Yeah, absolutely. And that's one of the best things about .NET is that .NET has the best tooling on the planet. I mean, you look at everything out there. Visual Studio is I mean, it sets the bar, right? And we are so spoiled as .NET developers by having these really fantastic tooling, and we support them across the board, right? So we have extensions for Visual Studio for Mac, the whole VS Code. It works on Windows, Mac, and Linux. And you can just go up here and you hit the big button, and it deploys to the device. You don't have to worry about any of the hardware plumbing, etc. You just hit the button and it goes. And you can even use Rider and the CLI, so you can really do this anywhere. Use all of your favorite tooling, all of your favorite tools, and have all that fantastic productivity that comes with that.
I like that you said that we're spoiled, and I think it's funny because that might initially come off as a negative thing, but it's exactly what you expect from a high quality production ready system like this? I want to be spoiled. I want to feel spoiled. I don't want to have to worry about the little details. I want to have to worry about the business problem, whether that business problem is working on my my greenhouse or automating my, in my case, like my blood sugar or my house or my smart lights, all the different things that I could potentially do. I want to call out though that when you do a hello world in IoT land, it's all about blinking the LED. You know, I remember when you showed me Meadow years ago for the very first time, and we sat down in a coffee shop, and you had a breadboard, and you had they had the little tiny Meadow chip, and you had a LED, and you said, "Look at that! We blinked an LED." That's Hello World, and that's exactly what Hello World should be in the IoT land. Why is it that I can't just 3D print a box and put that blinking LED into production? Why does production become this immediately complicated thing in the IoT world?
Yeah, that's exactly it. Because you can imagine, okay, so you've got to production, you've made some awesome IoT product, and it works. It's fantastic. It does the thing that you want to do. You know, it runs your greenhouse. But now all of a sudden, going to production adds a whole new set of concerns, right? So, for example, once this device is out there, you need to be able to do a whole lot of things, such as like, okay, let's say there's a new security update, and part of our SLA, part of the understanding is that as you use these devices, if there's a security update to the OS, we're going to give you that update. You need to be able to push that security patch out, or if you build a new feature, right? If you build a new feature, you need to be able to push that out to the field. And you also need to be able to tell if your devices are alive even. Can you imagine you've got these devices out in the field, and if you don't have a way to monitor them, how would you even know if they're even up, right?
You know, people can't really understand the scope of IoT until they think about how many humans there are, billions, but then how many interactions we have with devices, whether it be a thermostat or a light or a sensor or walking through a door. I'm a diabetic. I've got 2 different implanted devices and 4 different IoT things that are happening, and I'm only one person. So the combinatorics become really amazing. And then if you think about, I'm imagining this blinking LED that's been deployed. Let's say that we were going to have it manage the health of like a defibrillator at a mall. So I'm a company that manages defibrillators, and I have a blinking light that tells us whether or not the defibrillator is healthy, and there's some sensors. And then start doing the combinatorics. And there's thousands of these things. And to your point, that thing's got to work. I've got to update it over the air. Now, why is that over the air update so difficult? Because I don't like Windows Update, you know, shutting my system down, but this isn't a microprocessor with a full operating system. It's something else. Why are over the air updates of apps and Meadow OS challenging, and how do you solve that?
That's right. Actually, so there's a lot to unpack there. So the first thing is that, you know, there aren't a lot of IoT devices out there. In fact, today there's 2 IoT devices for every human on the planet. And in like 4 years, that's going to double, right? So we are growing exponentially in this space. And I remember when we started Xamarin, I used to go around and I used to give this talk, which was basically, if you're not paying attention to mobile, you're not paying attention, right? And the same thing is true with the IoT revolution. If you're not paying attention to this, you're almost not paying attention, because this is going to be a big employer of the future. If you're a developer out there, there's a good chance that in the next few years you're going to be building IoT devices. And as you said, like, that's the combinatorics there, the sheer math of actually going and updating these devices. Can you imagine if you had to go out to an installation that had maybe 1,000 or 10,000 devices? And that's not atypical of some large industrial operation, is to have 10,000 IoT devices. And if you had to plug those, you know, you'd go out and plug a USB into every single one of those devices, it would just be, you know, it just something that would be totally unmanageable. And then if you had to drive from site to site to site, you can imagine like windmills, right? And you've got these windmills, and they're scattered out across many, many miles, and you have to go from device to device. And the challenge here is that these over-the-air updates are just not built into traditional IoT platforms, and it's really hard, right? Because you have to have a bootloader. You need to be able to do an update like that has to be secure. You need to make sure that someone can't just walk up and do a side load, just plug in a USB and drop their own app on there. And you want to make sure that like when you send out an update, that's actually signed, and the device can validate that it came from the right place, and that it's when you push data over the air that it's encrypted and whatnot. And then there's also other concerns with devices in the field, right? Because it's not just updates and it's not just health. You also have like the challenge of data integrations, right? So you've got all this data that your devices are creating, and that's not very useful on the device, right? You've got to get that into the cloud. You've got to get that into your own backends. You got to be able to visualize that, whatnot. And that begets another challenge, which is like, okay, so let's say that I have this installation. Let's say I have thousands of spinning windmills, or I have got commercial nurseries, and I've got 100 nurseries out there, and I need to be able to control, and I need to be able to look at the state of those nurseries, right? That brings in like these other challenges, which is like, you need to be able to do remote control. So maybe something's coming in, maybe that it's going to be really, really hot today. It's going to be 110 degrees, and you need to open all the vents on these greenhouse preemptively, right? And so being able to like send command and control out to those devices, and also being able to like visualize a virtual representation of those assets in the field, which we call digital twinning, being able to view those and interact with that. That's also super important, right? So there's a whole lot of these concerns that happen, as you say, when you start to go to production.
We've got some friends on the chat here who have a couple questions. We have one individual who actually was managing 600,000 plus devices and was trying to plan those over-the-air updates. And you have occasionally connected scenarios. Devices go out of coverage, uploads fail partially. You also mentioned this digital twinning. Maybe you can show us how we can visualize these devices, and what does that look like?
Yeah, absolutely. That's a fantastic segue. Why don't we jump into Meadow.Cloud and see how this all works? So if you can pull up, there we go. So here is a list of some of my devices, and this is Meadow.Cloud. And what we see here is that I have an IoT device deployed to my greenhouse, and then I've got one sitting on my desk here, and that's the one that's showing up on the stream there. Hello, that's my Cultivar office. And what's really fantastic about this is if I refresh this page, I can see, first of all, look, it's alive. I sent, it checked in 2 minutes ago. I can do really neat stuff. Like, for example, I can send a command. Like, let's say I want to turn the fan on. I can come in here and I can say is on true. And we got this nice JSON editor here. And we send this command, the command goes. And then you see on the device, if you pull that device up, Adrian, you can see that it went on, right? We've got a little bit of looks like we've got a little disconnect on what the water versus fan is, but we did actually turn that on. And if we go back here, I can go and send another command, and I can turn that off. And so here's command and control. That's a really awesome thing to see. And as I mentioned before, we've got all this health reporting, and there it turned off. And if you come in here and you see, if we go to logs, what's really fantastic here is that I was doing some work yesterday, and you can see that I was deploying out apps that were actually failing, and here's my inner socket exception, and I can see, no such host was known. It probably wasn't connected to the cloud at that moment. And then we can go in and see events. So this is really, really awesome. And this is something that you basically get for free. I'll jump over the code for a second. But if I click in here is a device health message. And this shows my CPU temp. It's got how much space is used, how much memory is used. And here's another event, which gives me an atmospheric reading. And here it says, my temp, my humidity. And what's cool about this is I mentioned that this is all free, right? So if we go into the code and we see, here's the code for, says start updating. So this is basically when we start reading all the data from the sensors. And so we get this event that comes in, we read, and here it is. We get this data, and we pull this apart, and then all we have to do is get our cloud logger and log our event to the cloud, right? And it's all just automatic and free.
Let me ask this question here on behalf of William in the chat, who makes a really great point. We have two things going on here. We talk about the massive combinatorics and how you might have 10,000 of these devices out there. That UI that you just showed may not be usable at 10,000 devices, or even, several thousand. But then we have another question from Olivier, who's asking about, well, can I connect maybe an API and have my own management, so I could have a device management app because I have so many devices? How would I filter in? Could I make like a map of my, I don't know, my estate or my giant smart building, and then click and then click and then click? How do I get into that when I have more than that UI can comfortably handle?
Yeah, that's a fantastic question. And so the magic about this, the magic about the Meadow.Cloud is it basically is about device management, right? And that means getting data into the cloud and managing those devices. But the real power behind this is the integration. So let's say that we've got hundreds of thousands of devices out there or whatever, and we want to actually visualize those devices. We can do that with other integrations. So here is, for example, here's a data cake integration. This is something we have in preview right now, and this is actually getting data from the Meadow.Cloud. So when we log that sends up to Meadow.Cloud, and then we've got an integration that says, okay, let's configure it to push these pieces of data over to Data Cake. And so Data Cake offers like fantastic visualization. And so here is the temperature. You can see last night it got a little cold, and so I turned on the heater, and it started to get warm up in here last night. And then as the night came in, it cooled off. And then also here is humidity. So we actually had some moisture come in last night and drive our humidity up quite a bit. And then today, again, this morning, we had fog come in. And integrations like this make it super easy to visualize not just a single device, but of course, these organizations, these services like Data Cake make it super easy to visualize lots and lots of devices.
Right. So let me ask you this, though. You've got lots and lots of devices. Maybe I can group them. There's device grouping I know that's being thought about. But then the combinatorics become so complicated. Is that why you bring in tools like Data Cake? Because William makes the point, you might have data points. So you have N number of devices times, X number of data points over time. You could be into the billions of records very, very quickly. That's not necessarily Meadow.Cloud. It becomes the router at that point, but there are existing tools for managing data at that scale. Is that correct?
Yeah, 100%. In fact, one of the major integrations we have is Azure Event Hubs. And so that scale is exactly what Azure is built for, right? So you can ingest that data via Azure Event Hubs, and then you can push it into any system you want. In fact, one of the integrations that we have here is with Azure digital twins, right? So here's a digital twin, and this is, a digital twin is just a virtual representation of a real world thing, right? And it could be a device, it could be a group of devices in the case of like an asset model. So in this case, we might have a greenhouse with a bunch of devices, and the power of this is that if I go over to my project lab here, so if we pull that one up and we highlight the project lab, you can see I can hit the button, I can turn a thing on, right? I can turn that on locally, and that synchronizes with the cloud, which then would be ingested into a system like Digital Twin. So if we pull the Digital Twin back up, and then I go run, I refresh this query, you can now see that is on, right? And so you could actually orchestrate, you could perform an orchestration of hundreds of thousands of devices or even millions of devices, because that's the power that we have here of pulling stuff into a big backend like Azure.
That's great. So Meadow.Cloud is that connector piece, but it's not trying to be a cloud like an AWS or an Azure. It is the IoT missing piece that helps you ingest that data, receive it, do the over-the-air updates, manage the devices, the packages, and the integrations. But then when it comes time to deal with your 27 billion records, that's when you lean on those big cloud vendors and those tools. And that's where these integrations come in, and why that integration point in Meadow.Cloud is so important.
100%. So that's exactly it. You can think of Meadow.Cloud as really just device to cloud and device management, right? So Meadow.Cloud makes it super easy to get the data off the device. And with Meadow, you can also just talk to your backend integrations straight, right? There's a whole network stack. You can open up a RESTful client, you can talk to your backend, or you can put it through the cloud. It doesn't really matter. It's up to you. The nice thing about the cloud is that this will automatically push those into those integrations, and we handle those disconnected states, right? So let's imagine that your device doesn't have connection, something happened, device is no longer connected, and you're logging those things to the device. What happens is that the device will actually store all that data locally. When a connection comes up, it will then upload that to the cloud. And the same with the commands, right? You can send a command that goes into some message queue and do an MQTT message queue. When the device connects, it gets those messages, and they can do its thing.
Question in the a couple of different people are asking about earlier versions of Meadow. There's different versions of the Meadow board. People that may have bought a Meadow before. Is Meadow.Cloud for all Meadows?
Yes, 100%. So Meadow.Cloud today supports all Meadow devices, whether it's a Meadow Feather V1, Feather V2, or a core compute module based device such as the Project Lab or some of our other IoT accelerators. And we are working on support for other devices as well. So we've got an internal beta today of Linux support, so you can actually run this on Raspberry Pi or other embedded Linux systems, and as well as Meadow desktop. So we've got Meadow running on the desktop, and we've got a simulator that we're working through. And then in the future, on the roadmap is being able to do this with any microcontroller device out there, right? And the whole thing from OTA updates to data and to the messaging APIs, everything. And speaking of remote control, one thing that I forgot to answer there in one of the questions was, can I access that remote control other ways? And the answer is absolutely yes. So everything that you see in the Meadow.Cloud API, everything in the Meadow.Cloud UI, everything that you see here is actually accessible via an API. So you can integrate this into your CI/CD pipeline. You can integrate this into any application you want. So you can make sure that, like, if you want to push out OTA updates, you can integrate that into your Azure, your GitHub CI/CD pipeline. You can push those packages up to Meadow.Cloud, and then you can use the APIs to manage them from your own backend and dashboard. Anything that you can do in the UI is accessible via API as well.
There's a couple of questions a little bit back farther, and I want to connect them to Meadow.Cloud. So someone says, where do the drivers for the sensors originate? They might have some existing cheap sensors for Arduino. How does he know that they're going to work for Meadow? And then once I've got a great sensor that I'm excited about and I plug it into my Meadow, does Meadow.Cloud care about a particular sensor, where it came from, or is it just taking that data and then routing it into those digital twins? How do I connect my favorite sensor from some unknown brand to a Meadow and then get it into the cloud?
Yeah, so unpacking that, there's two sides of this. One is getting kind of the sensor working with the Meadow, and that is generally super easy. There's probably, if you grab a sensor off of Adafruit or SparkFun or DigiKey, first of all, there's probably already a driver for it. And if there isn't a driver for it, you can go to Meadow Foundation repo, and you can actually go look at an existing driver. So you can see in here, we have under peripherals, we have really, like I said, there's hundreds and hundreds of drivers in here. And so let's say you've got a new, maybe Bosch comes out with a new fancy BME 742. You can actually come in here and you can actually see how this driver is already created. And you can use that as a template for your new driver. And of course, with ChatGPT, honestly, we've been writing drivers with ChatGPT, and that's been a real boon in productivity because it actually pulls in a lot of the code that you
Well,
need
and
to write.
that actually speaks to like the idea that that the answer to that question might be write your own driver is actually less scary than you think, because Meadow has hardware support, and even on my Project Lab device, I've got ports for plugging in and prototyping that are standardized port sizes. So I will have the connector. I've got the pinouts. I'm really set up for success when it comes to doing this kind of stuff.
Yeah, absolutely. And that's the cool thing about the project. What I really love about the Project Lab is that it literally has these connectors, right? You've got Grove, analog, digital, UART. You've got a STEM Acuity, which is the Adafruit SparkFun connector for I2C. You've got RS485, so you can do industrial like Modbus sensors and things like that. And then you've got these microbus slots, so you can drop in clickboards. And the power of this is that you can prototype very, very quickly. You can basically instantly put together any hardware. You just assemble the hardware without having to do the soldering, without having to do any breadboarding and whatnot. You just plug it in and you go. That's right. You got a great picture right there of exactly that. So those boards you can plug right into the Project Lab.
Yeah, that's really exciting. That's actually my Project Lab V3 right there. And then I've got tons of sensors around that I'm going to want to prototype with, and being able to have that flexibility has been a real boon for the kind of stuff that I want to do around my house.
Yeah, that's right. And going back to that original question about driver or sensor data to cloud. So once you have the sensor talking to your Project Lab board or your Meadow board, which as we saw was super, super easy, getting it into the cloud is even easier, because all you have to do is call this. If we pull up all you have to do is log it, right? And you can see here, this is just a dictionary of values. And these could be anything. These could be, we're reading these from that particular sensor, but you could read these from any sensor, from any input, and logging it to the cloud is super easy. You simply call your cloud logger, log event, give it an ID, and pass in your dictionary values.
Well, then let me take this question then from Kelly, who wants to know about best practices. If you've got a lot of these devices, what about payload efficiency? We're not just shoving REST APIs and XML around anymore. We want to send the smallest amount of information possible on these tiny low power devices.
Yeah, that's right. So that's actually a super awesome question, because this is a thing that we're working on right now with making sure that this is hyper efficient, right? So we're making sure, we've done a couple of things here. There's some things that we've done internally to make sure that when you are actually reading sensors, so there's efficiency in reading them, so that you can read a bunch of sensors at once, and then you can put the device to sleep, and device will wake up when you want it to, maybe an hour in the future or whatever. So you're efficient with power. And then in terms of bandwidth, we're doing the same thing here. So we're actually writing all this sensor data down to the device, and then we can batch upload that sensor data or whatever data to the cloud, right? And we're actually working right now with giving you control around how that data gets batched up and how and when it gets sent, right? Because you may not want a super chatty thing. You may be designing a piece of IoT that might read a sensor every minute, but you only need to push that data up once an hour, right? And so giving you that control over doing that's something that we're working on. You can also control that internally today with your app.
That is a really great point, and I think that's another interesting one. In my business in the past, I worked in banking, and the business person, the suit, would always say, "I need real-time updates," but they always felt like real time meant instantly. But the business problem might be real time for one business is 10 seconds, and for another one it's 5 minutes, and for another one it's aggregated real time data. It's the trend as much as it is. And those kinds of decisions can be made in your architecture, and Meadow.Cloud will support them regardless, right?
Yeah, that's exactly it. Because sometimes, like you said, real time might actually mean that the data doesn't necessarily get to the cloud immediately, but rather you have 1 minute intervals of reading a sensor, right? And so it's really up to you how you want to do this. And we make it super easy so that the Meadow application, you can write an application that fits your business needs and not focus on the hardware. Just focus on building your application, solving your challenge. And this, what's really cool about this, I forgot to mention this earlier, is that this works over any radio connectivity, right? Whether this is Ethernet, whether it's Wi-Fi, whether it's cellular, right? And it's super easy just to drop in a cellular module on the Project Lab board. You can drop in a microbus cellular adapter, and you configure it in your app config, and then all of a sudden you have a full network stack and full network connectivity over cellular, right? And it looks the same.
Let me dig in on that for a second. So you're saying that I write to the network stack. I'm doing my prototyping here on my Project Lab board using Wi-Fi. I pop in Meadow Cellular. Do I have to go and then rewrite my code that accessed the network?
Not at all. Not at all. What that gives you is you can pretend like it's like a computer in which you have just swapped your Ethernet your network interface. Maybe you turned on your Wi-Fi, you've turned off your Wi-Fi, and you've plugged in an Ethernet. It's the same thing, cellular, all of it's the same. We don't force you into any sort of like messaging through some proprietary cellular stack. What you get is just a network stack. So when you go to make an HTTP request, it doesn't matter if that request is over Ethernet, Wi-Fi, or cell. It's all the exact same thing. It's the exact same code. You have to change nothing in your app other than to configure your internet device.
What about some more, not obscure isn't the word, but some more custom things like low raw WAN, you know, the low power wide area WAN network?
Yeah, absolutely. So that stuff is baked in, and there's some great examples on the internet. In fact, there's Bryn Lewis down in New Zealand actually made a really fantastic example of this is on Hackster. If you just search Meadow LoRaWAN, you can see here he's got Meadow Feather, he's got a LoRaWAN or a LoRa device plugged in, and you can just start coding and start messaging over
and
LoRa.
This gets back to the Lego analogy where people are plugging stuff in. You've got the standards, you've got the pinouts, you've got the stack. It's at the right layer of abstraction. You can cause all kind of good damage with this.
That's right.
Commenting in the chats here. This would be great for working in the agricultural field. People are talking about data efficiency. Lots of exciting questions and comments going on in the chat. We've got digital twins. We've got command and control. We've got health logs. We've got, what about crash reporting? What if things go wrong? How am I going to wake this guy up if there's an issue? Is there a watchdog?
Yeah, absolutely. That's really what a great question. So if I actually go in here, you can see if I look at the logs, I was actually getting errors before. And what we have is a hardware watchdog. So if we go into our Meadow app here, here's this, we've got this, we basically say wire up watchdogs and start petting watchdog. And basically what this does is, this is a hardware thing, right? So on the hardware itself, there's a dead man switch. And it says, if you don't pet the watchdog, if you don't tell it every 30 seconds or whatever that you want to make sure that this thing is still alive, it will actually restart, right? And this is super interesting and super important for stability, because you may have to actually do this, right? You may have your app may crash, you may have some bug in there. And if that device doesn't restart in the field, someone has to go out and touch it. Someone has to go out and actually do something. And this makes it so that you don't have to. The hardware will automatically restart it and you're good to go. Move on.
All right. So what's the big announcement today? What is special about today?
Yeah, so I am super excited. Meadow.Cloud has previously been private beta only, so customers had to request, and it has a manual process to get you in on the beta. And today we have opened it up so anyone can go to meadow.cloud.co and can sign in, can make an account, and can attach their Meadow devices to Meadow.Cloud and get going.
That is really cool. And I saw they're free for up to 25 devices, which is very, very generous, which is going to set me up for success. You're going to be able to run effectively your entire your entire garden there as a development thing. And then when you're ready to go into production, you can just upgrade from the development to the production.
Yeah, that's right. So it's a freemium model. If you're a developer, you never pay anything and you get the full access to the Meadow.Cloud. But when it's time to go out to a commercial deployment, then, it basically winds up being about $1 a device a month. And that gets you all of the integrations, that gets you all of the power of Meadow.Cloud. And you can go out there and you can build real professional IoT and maintain them in the field.
That is cool. Positive heads up and feedback from the folks in the comments. People are digging this. So I can sign up for this today. This is the announcement. This is out and it's ready to go.
100%. Go to Meadow.Cloud.co and sign up and create an account, and you're in, and pull out your Meadow devices and start attaching them, and go check out our documentation. We've got fantastic documentation on getting started with Meadow.Cloud. So if you go to our developer site and you go down and you find the Meadow.Cloud docs, they're all there, so you can get up and running. And of course, if you don't have a Meadow device, you can go to the store and go pick one up. Go pick up a Feather or go pick up a Project Lab board. I highly recommend picking up a Project Lab board, because the magic of the Project Lab board is that it's IoT in a box, right? Everything that you want to do, you can either plug in or it's already built in. It's got a display. It's got built-in temperature, pressure, humidity, light sensor. It's got a 9-axis accelerometer. It's got a speaker on there, and like I said, it's got I/O for RS-380, 485, so you can know industrial stuff. It's got these fantastic micro bus slots here, so you can there's thousands of microelectronica clickboards you can plug in. It's got the Grove plugins. You can just go to Seed Studio or Adafruit or SparkFun, buy anything you want, plug it in, and just go.
Very, very cool. And this is not theoretical. There are customers that are building on this today that are working on this.
Yeah, 100%. This is, this is really a professional platform, and we have a pile of really fantastic customers. Some of the folks that we have building stuff, we have the Navy is using Meadow to do maintenance ops. So you can imagine you're going to maintain a boiler in a Navy boat or something, and you walk up to it and you have real-time information about what's hot, what valves are on, and information about how can you perform maintenance. In fact, your wastewater treatment in your county, over in Washington County there, Hanselman, they're integrating Meadow to get data from places where they were not previously able to put compute, like out in their natural treatment facilities and the upstream streams, as well as in their facilities. They're using Meadow to actually read sensors out in the field and put that into their SCADA backend, right? We also have folks, Jeff Julian has built a bunch of open source automations for small scale sustainable farming. This is a place where it's really difficult to actually run a profitable small scale farm, and he's done automations with Meadow to make that so that other farmers like him can actually run profitable farms with Meadow. So yeah, absolutely, this is out in the field. People are using this and they're building real world applications.
Very cool. So folks can sign up. Meadow.Cloud, 25 devices in development, very inexpensive in production. You get command and control, you get health logs, you get automatic crash reporting, you get event logging, you get enterprise integrations to plug into your favorite backend. You get that digital twin if you want. You can do data cake, which is in preview. All of these things are happening. The networking stack, question, it was amazing. The idea that I can just write to a networking stack on a microcontroller and I could swap it out for cellular if I wanted to is fantastic. And then free dev access, of course, to Meadow.Cloud is going to be fantastic for proof of concept projects, as we can see folks in the comments appreciating that as well. And also .NET, like you said, it's full .NET. If you know .NET, everyone who's on the call right now who isn't a Meadow developer just became a Meadow developer because they are already .NET developers. So that makes me feel very empowered. I've got my project lab right here, my project lab board, my sensors, and I can go and play with this stuff right now. This is great. Look at this. So this is a project lab. This is right here, actually just using the sensors that are on the device itself. And I haven't plugged these in yet, but the world is your oyster with one of these devices. And I'm looking forward to playing even more. Congratulations to you and the team for quite an accomplishment.
Thanks. It's been a long road, but you know, it's the hard problems that are worth solving, and ultimately, you know, the thing that keeps us going is that we're building something that we want to use. Right? We're all engineers. We're all .NET developers, and we wanted something that unlocked hardware for us and made building hardware is really just like building a mobile app or a web app in .NET.
That's so cool. And this is all Apache licensed, open source, amazing hardware, amazing software, really great community, more drivers, more sensors every day. And now today, the Meadow.Cloud is ready to go. This is fantastic. Thanks so much. This is, I'm very excited for you. I just feel happy when my friends and their teams are having such a good time building things that make other people feel empowered.
Yeah. And thanks for all of your support over the years, and thanks for coming on and helping me co-host this. I couldn't have done it without you.
All right. It's the Meadow.Cloud launch, my friends. Bryan and the team at Wilderness Labs has built something really special here. I hope that you all check it out. Be sure to go to the store. Be sure to go to Wilderness Labs and also sign up for Meadow.Cloud. If you're going to take a screenshot, this is the screenshot to take and tell your friends. And of course, this has been recorded, so I hope that you return and share with your friends and your colleagues. Bye, everybody.
All right. Well, thanks everyone. Thanks for joining, and we will see you online.